Our planet, Earth, is always moving. It's constantly spinning on its axis, a bit like a giant cosmic top. This rotation is what gives us our day and night. At the equator, the widest part of our world, the surface is moving at a remarkable speed. It travels at about 1,670 kilometers per hour. This might sound incredibly fast, and honestly, it is. However, because everything on Earth, the air, the oceans, you and me, is moving along with it, we don't feel this immense speed at all. It's a constant, steady motion that has shaped life as we know it over billions of years. This constant spin has defined the rhythm of our world. It creates a cycle of light and darkness that lasts roughly 24 hours. This cycle is fundamental to almost all life on Earth. Plants use sunlight for photosynthesis, and many animals have adapted their behaviors to be active during the day or night. The length of our day is a direct result of this rotational speed. It's a delicate balance. The speed is just right to create a stable environment where complex life can thrive, providing a predictable pattern of warmth and coolness, light and shadow that governs our very existence. Imagine standing on a merry-go-round that is spinning smoothly. Once it reaches a steady speed, you can almost forget you are moving. The Earth is much the same, but on a far grander scale. Its rotation is so consistent and smooth that we are completely unaware of the incredible journey we are on. We are all passengers on this vast spaceship, hurtling through the cosmos. The ground beneath our feet feels solid and still, but it is actually a platform moving at an astonishing velocity. This silent, powerful motion is one of the fundamental conditions of our existence on this beautiful blue marble. The speed of this spin is not the same everywhere on the planet, which is an interesting detail. If you were to stand at the North or South Pole, you would simply be turning in a small circle, hardly moving at all. The fastest speed is at the equator. As you move away from the equator towards the poles, the speed of the surface decreases. This variation in speed has profound effects on our weather systems and ocean currents. It's a complex and beautiful dance of physics, all dictated by the simple, steady rotation of our home world as it journeys around the sun. So, if the Earth is spinning so incredibly fast, why don't we all just fly off into space? The answer lies in a powerful, invisible force called gravity. Gravity is the force that pulls objects towards each other. Our planet is massive, and its immense mass creates a strong gravitational pull. This pull is constantly tugging everything downwards towards the center of the Earth. It's far, far stronger than the outward force created by the planet's spin. This is why we, and everything around us, stay firmly planted on the ground. Gravity is our anchor in the universe. The outward push you might feel from spinning is called centrifugal force. It's the same force that you feel on a fast-spinning fairground ride, pushing you to the outside. On Earth, this force does exist, and it's strongest at the equator where the spin is fastest. It slightly counteracts gravity, making you technically weigh a tiny bit less at the equator than you would at the poles. However, the force of gravity is about 300 times stronger. This overwhelming dominance of gravity ensures that the centrifugal force is barely noticeable in our daily lives. It's a constant, silent battle of forces that gravity wins with ease. Think of it like this. Gravity is a giant, invisible rope, tethering every single thing, every person, every building, every drop of water, to the surface of the Earth. The spin of the planet tries to slightly loosen that rope, but it's not nearly strong enough to break it. This delicate balance is crucial. It allows us to have a world with stable oceans and an atmosphere that clings to the surface. If gravity were much weaker or the spin much faster, our world would be a very different and likely uninhabitable place. The security we feel is a gift from our planet's immense mass. This balance of forces has been stable for billions of years, allowing for the slow and steady evolution of life. The structures we build, from our homes to the tallest skyscrapers, are designed with the assumption that gravity will always hold them down firmly. Animals have evolved to walk, run, and fly within this constant gravitational field. The entire biosphere, the very fabric of life, is woven around the certainty that gravity will always keep us grounded, no matter how fast our world spins through the darkness of space. It's the most reliable force in our lives. Now, let us imagine the unimaginable. In a single, terrifying second, the Earth's rotation at the equator speeds up by 1,000 kilometers per hour. The new speed would be a staggering 2,670 kilometers per hour. The first thing that would happen is not something we would see, but something we would feel. Everything that is not securely anchored to the planet's bedrock, people, animals, cars, trees, and buildings, would suddenly be thrown eastward at a tremendous speed. The ground beneath our feet would accelerate, but we and everything else would be left behind by inertia, the resistance to a change in motion. This would create the most powerful wind ever experienced on Earth. It would not be wind in the normal sense, but a supersonic shockwave of air. The atmosphere, not moving as fast as the newly accelerated ground, would effectively become a destructive force, moving at 1,000 kilometers per hour. This wall of wind would scour the surface of the planet, instantly demolishing every man-made structure. Buildings would crumble into dust. Forests would be flattened in an instant. It would be a global cataclysm, a physical force so immense that nothing could withstand its power. Survival in such an environment would be impossible for any life on the surface. The oceans would react with equal violence. The sudden lurch of the planet would send the vast bodies of water surging eastward. This would trigger mega tsunamis of a scale we can hardly comprehend, with waves potentially kilometers high. They would wash across entire continents, sweeping everything away in their path. The sheer kinetic energy transferred to the water would be phenomenal. These waves would travel at incredible speeds, eroding coastlines and reshaping the very geography of our planet in a matter of hours. The map of the world would be redrawn by this catastrophic surge of water. Simultaneously, the planet itself would feel the strain. The rapid acceleration would likely trigger immense geological instability. We could expect a dramatic increase in earthquakes all over the globe as tectonic plates grind against each other. Volcanoes, long dormant, might erupt violently as the planet's crust adjusts to the new stresses. The very ground would become a chaotic and unpredictable place. The sudden change in momentum would send shockwaves deep into the Earth's core, potentially disrupting the magnetic field that protects us from solar radiation. In 1 second, our stable world would become a maelstrom of wind, water, and fire. If any part of humanity were to survive the initial cataclysm, perhaps in deep underground bunkers, the world they emerged into would be alien and hostile. The most immediate change would be the length of a day. A faster spin means a shorter day. A day and night cycle would now last only about 17 hours instead of 24. This would fundamentally alter the rhythms of light and darkness that all life has adapted to over millennia. The shorter, more rapid cycles of warming and cooling would create even more extreme and chaotic weather patterns than the initial disaster. The change in centrifugal force would have a noticeable effect. At the equator, the stronger outward push would counteract gravity more significantly. Everything would feel lighter. This might sound pleasant, but it would have devastating consequences. The oceans would bulge even more at the equator, drawn there by the increased centrifugal force. Water levels near the equator could rise by many meters, permanently submerging vast coastal regions and islands. Conversely, water would be pulled away from the polar regions, exposing new areas of the seabed. The world's coastlines would be completely and permanently rewritten. Life on this new Earth would be a constant struggle. The relentless high-speed winds would continue to rage as the atmosphere tries to catch up with the planet's new spin. These permanent gales would make it impossible for complex life to exist on the surface. Plants would be unable to grow, and any animals that survived the initial event would find it impossible to find shelter or food. The sky would likely be filled with a permanent haze of dust and water vapor, obscuring the sun and creating a dim, perpetual twilight. It would be a bleak and unforgiving landscape. This thought experiment, while terrifying, is a fascinating way to appreciate the delicate balance of our planet. It shows how forces like gravity and rotation, which we take for granted, are perfectly tuned to allow life to flourish. By imagining such a radical change, we gain a deeper understanding of the physics that governs our world. It highlights the stability and predictability of our planet as a truly precious and perhaps rare gift in the universe. The gentle 24-hour spin of our Earth is not just a feature of our world. It is the silent, constant heartbeat that allows us to be here at all.